Wow, nice room. Lots of people here. I love this new venue, M+, never been. Look, I want to broaden the scope a little bit of what I'm going to talk about next. I think we are in this pivotal moment of technology again, and you know what I'm going to say next, because of things such as artificial intelligence. Now, as I talk to some of these artificial intelligence things here, we want to think about how it can be used for the good. And I'm going to start with the good, because it's always nice to start with the positive. And then we're going to have a look at how it can maybe also be misused for malicious intents. Having said that, though, I always like to kick my talks off by saying technology is rarely a revolution. Right? This entire generative AI thing hit us really quickly, and it feels like something that came like a revolution. But it really very much is an evolution of neural networks and all the research that we've done over the past many decades, actually. You know, if you think about it, you remember that research paper, Attention is All You Need, was published in 2017, came up with this concept of transformers, and was originally actually published to improve the way we do neural network language translation, translate from one language into another language. And somebody quickly figured out, well, if I feed that transformer with lots and lots of data, I get a very eloquent large language model, nowadays even large visual models, that allow us to really build these intelligent AI assistants. Why is it relevant to think about that? 2017, that's 3, 4, 7 years ago, right? So it's all not that new. And we see that there's a constant evolution on these models, no matter which provider of choice you're going to use. I would encourage you to use AWS, but I'll leave you up to what you want to use. But these iterations on these models are constantly evolving in the capabilities of what these tools can do, and also how relevant they become across any kind of job functions. I believe it's pivotal because it's similar to when we had the first graphical user interface. Suddenly, everybody can start using a computer that knows how to operate a mouse. Generative AI right now is super powerful in many different areas. I mean, you might have seen it to create some funny pictures, and we're going to talk about that later on how that can be used for disinformation. But where it's really powerful is that better improved customer experience, that overall improved operational efficiency that I have. No matter if it's in the obvious stuff like sales and customer service support, you know, to creating content creation for marketing purposes, but down to where legal and HR teams are using these tools on a daily basis with a lot of information out there because it makes them more efficient, down to software engineering, you know, where we have code generation, code documentation, all of that being created using generative AI. I believe that's cool, that's great, because it makes us a lot more efficient, a lot faster. And if you're interested in some of the actual customer numbers, pop by our booth later today. But it really transforms across every kind of industry, from some of the obvious stuff like, I don't know, sentiment analysis on stock trades using that New York Stock Exchange is doing, and Thomson Reuters is doing that, to the visual space like Leonardo AI, just recently acquired by Canva, allows you to render images and videos by using text to image, to some of the lesser known scenarios, such as United Airlines recently used it to take their PNR systems that run on a mainframe. These are these passenger records, these cryptic messages. And they put generative AI in between, excuse me, as a translation layer. So you don't need to actually operate the mainframe or that specific PNR records. You don't need to how they need to look like. You can just use a generative AI tool to actually talk to it and now integrate it into your call center. DoorDash has done something similarly, all the way to revolutionizing how you maybe do travel. Say, I'm not going to go to booking.com and book a hotel. I just say, I'm going to Paris tomorrow. Help me plan it, right? Now, that's the opportunity. But that then obviously comes with the risk of saying, well, how do I protect and secure these kind of workloads? And let's start off with the basic stuff here. If we talk about these generative AI models, we often refer to these things as foundation models, these pre-trained large language, large visual models that have been trained by Meta, by Anthropic, by Microsoft, whatever, various different providers, Amazon, etc. I believe, though, these foundation models are table stakes, right? Because they have been trained on large amount of common crawl data, Wikipedia data, some proprietary data sources, but everybody gets access to those same models. Great, we democratize this space, but it also means that that true value and competitive difference, which is that overlap of your data, from your data lake, from your Salesforce data, from your ERP CRM system, how do we get that into those models, right? Traditionally in machine learning, what do? I take my data, I retrain the model with all my data. If I do that with a generative AI model, with the transformer architecture, I just managed to leak my entire customer database into a model. So we obviously can't do that. Now, obviously, as you probably know by now, I love how sometimes we come up with really fancy names, such as retrieval augmented generation, which is really just putting your data into the prompt before sending it off to a model. These are techniques that allows us to load data on the fly, and when the context is dropped, not having the data leaked into the model. Okay, that's great. So I can move my data into the model, live load that, and there are many different services out there. From our perspective, it will be our Amazon Bedrock service that can help you do that. But the other thing that I believe is there's not going to be one model that's going to rule them all. Right? We're not going to take the latest and greatest model and connect it to all my data. But rather, and by the way, this is a term that was coined by Gartner lately, they call it agentic AI. Not one model that's going to rule them all and know it all, but rather you call the right model based on the context, and maybe those models call other models that get triggered based on the context, and we load data up on the fly. That is the way we want to implement generative AI. What that means is most people within your company, unless they are the IT professional or the AI engineer, will not even know that they're actually using generative AI. Basically, just optimize their processes. But how do you go about that, right? You're not just going to create one big agent, one big model, but you can say I can have an entry model where generative AI is useful, where a large language model is useful, and then you define contexts. Right? And you integrate it into your existing enterprise resources. Here's just a very simple scenario. Let's say if I have something that sounds like a policy, how many days in advance do I need to book my leave? Send it to a small language model that has been only trained on your policy documents. But what if somebody asks something about themselves? How many vacation days do I have left? Do I send it to a large language model? I probably shouldn't, because then I hallucinate the vacation days. Maybe that's a good thing. Right? Maybe you want hallucination. But you probably should send it to your existing microservice, to your existing database, etc. And by the way, the credentials of that user that is logged in, you pass it through to those microservices. Very often this is done to tools such as LangChain. If you use something like Amazon Bedrock, we call it Amazon Bedrock agents that allow you to do that orchestration. But basically what it means is instead of sending it all the prompts raw to your model, you basically create a chain of thought, divided into the different steps. Some of them will go against knowledge bases. Some of them will be RAG, retrieval augmented generation. Some of them will just go to a default smaller language model. And some of it would go to make an API call against your existing services. Bring that data back, answer or do the action, whatever the agent is doing, then drop the context and drop with that the data out of memory. The other reason why this is relevant from our perspective, for example, we believe it's not going to be one model that's going to rule them all. There's going to be plenty of different models. If you use our managed service, which would be Amazon Bedrock, there's models from various different providers, from Meta to Cohere to Anthropic. You will see more coming here in this space, including some of our own Amazon models. The key point here, though, is not the model provider, but it's also the size of the models that matters. You don't always want the biggest model. Sometimes you want a much smaller model because of risk of hallucinations, because of things such as cost, and I'm going to get to that in just a bit. But the other thing, this is kind of the broad view of generative AI, I'd say, or AI in general, but especially generative AI. How do I secure that? And how can I maybe use it to, as a security professional, to use generative AI to detect threats a little bit faster? And then I'm going to round up in my last 5 minutes to just look on how we can have some of these threats because of generative AI and what we can do about it. The first thing that I would say is I started off by saying it's never a revolution. It's always an evolution, right? The same thing comes here. Anything that you've learned about security, apply those same concepts onto your generative AI deployments, right? It's still just a model that you run somewhere. Okay, we just learned we shouldn't train it the same way, but all your security audit compliance mechanism, attach them in the same way. Like I just said, if you do something like retrieval augmented generation, pass the login through. So whatever access control you had on your existing APIs, now will just get pushed through to that language model. In addition to that, it's as simple as using the existing tools that you know. If you ever used AWS, you know we have CloudTrail and CloudWatch logs, which allows you to understand any activity within your APIs and your accounts, and then you can take action on it. Well, if you have a generative AI model, you just say, anytime you have an invocation of that model, log it, push it to my CloudWatch logs. From there, I use my default mechanism of PII was detected, immediately block that situation, for example, or remove that out. And by the way, there are obviously also managed ways of doing that. So one technique is to say, before a model responds back to you, you send it to another model to verify if you didn't leak accidentally any data or if you need to mask some data out. So you guardrail your generative AI workloads. If you use a managed service, then it's also called Bedrock guardrails, by the way. So basically say, hey, if there's a bias, right, the result comes back. If there's a bias, such as this example that you see here, you probably really shouldn't send that back, right? You should redact the answer. If there's PII, you want to remove that information. But this can go as far as saying, does it sound like financial investment advice? If so, block the response, because you probably shouldn't give financial investment advice, unless you specifically want to build that and you're licensed to do so. Also, no matter which provider you use, if you use Amazon and you use Bedrock, you want to make sure that your models are actually not, that your data is not being used for retraining these underlying new models. So if you use Amazon Bedrock, of course, we keep your data secure and private, such as the usual virtual private cloud. You put your data in the same access control that you're used to. The encryption, in transit, at rest are obviously still applicable, but you want to make sure that you do that, of course. And as you customize some of these models, again, you are in full control and ownership of these models. But the same CloudWatch logics, IAM, access controls, etc., all apply. Now, there is an opportunity, though. I think as a security team, as a security professional, I should say, does that now mean I need to learn again all these new things? No, that's great. The same mechanisms that I'm used to, I can continue to use those. But I would encourage you also to look into, can I use some of these models to make myself a little bit more effective? Automated patching, automated upgrades. A lot of generative AI in the software engineering space, very often we look into, oh, it can write code for me. Yes, it can do that, but it can also help you maybe migrate to a newer version of Java, for example. Well, great. Right? So instead of doing all that manual patching, use AI to help you there. Maybe detect anomalies in configuration. Explain this file to me. Does anything look strange to you? As much as to reactive kind of scenario where you summarize a threat intelligence, right? LLMs are really good at understanding large log files, and you can ask any questions against it. If you do some threat detection, or you want to do an investigation against a log file, rather than going line by line, could you use a generative AI model to accelerate your forensics here? You probably could, and you probably should. Now let's have a little bit of fun, though. Never trust anything you see on the internet, says Margaret Scratcher, scratching away on the beach. I think it goes without saying that Margaret Thatcher probably, well, I don't know if she ever scratched, but certainly that picture is clearly an AI-generated picture. It's an interesting time, though. I mean, when was the first time deepfakes came out? Like 2016, 17? I'm not sure. A long time ago, right? But I like that nowadays people actually have applied that zero trust principle, because they say whatever I see on the internet, I'm actually not entirely sure if it's real. Now, there are many things that are being done in the industry, in the space. I'm not going to dissect that. I know there's some other sessions around it later. But the interesting thing here is as well, the weakest link very often is not the tools, but the humans that are actually using them. So one of the interesting things that you can do is use AI to train humans. Let's reverse the cycle here a little bit. So one of the interesting things with some of my customers are using these generative AI models is to say, any interaction that my salespeople have, my support agents, etc., I actually summarize it and analyze it using large language model. And I can even do things such as misalignment or off-brand statement, so that I can immediately find those problems and maybe retrain a person and say, well, actually this is the right way to talk about our brand. This is not the right way to address these kind of problems, right? So generative AI good at generating, but good at summarizing, and this is a good scenario for that. Summarize, analyze, have Gen AI as a new tool to help you make sure your human interactions with your end customers are done correctly. Even down to scenarios such as creating or simulate fraudulent activity using generative AI, sending it to an actual human and see if they identified it as a threat or problem on impersonation. Right, so some interesting techniques that we start seeing here being used where generative AI, again, makes us more effective here in helping people understand this problem better. And that goes down to like a default KYC process, right? These people do not exist, right? There's actually there's many websites out there, but this is one very well-known one, thispersondoesnotexist.com. And all the pictures that you see here are people that don't exist, right? So if I do that default KYC thing, like, look into the camera and shake your head and blink, is that still safe? Do I need to apply different measures? And now you're going to say, okay, that's okay. These are just pictures. It's a still, right? It's not going to work. The person's not going to blink. Well, there's wonderful tools out there that can help you take an existing still picture and then obviously do movements. What you see here, again, are people that do not exist, and these interactions have never actually happened. Here you see on the right-hand side, that's a Comfy UI, which is just a UI to use something like Stable Diffusion or others to do like winking and blinking and head movements, down to building an entire live portrait. And even other better technique is just to combine it with analyzing what I do of my webcam and then overlaying another picture of it. Now, there are tools, there are techniques to understand this, to see different pixel variations, to see how often someone blinks and see that it's not always correct. But the main thing that I believe is, in addition to implementing these tools, is that any security awareness training that you're going to build needs to be updated with what's the art of the possible, right? I think people are often not aware of how far these things have come, where I can really create a realistic video of a person looking at me, and it actually is not there. And I think earlier in the opening keynote here, there were a few good examples of, look at the right kind of MFA, two-person kind of authentication methods, etc. Is something even possible? Now, I want to end on a few predictions because I'm a bit short on time here. I believe bigger isn't always better because we need to be energy efficient, we need to be culturally aware, and we need to build AI responsibly. What do I mean with that? Well, historically, AI models used to get a lot bigger, right? From the GPTs to the switch Cs, where we have trillions of parameters that we kind of drive into these models. Lately, you see there's a lot of models that are actually quite small. Suddenly, we have these small models that people are building. And the main reason for that is that we identified that a larger model isn't always better. As a matter of fact, a larger model with trillions of parameters doesn't even get you close to AGI, Artificial General Intelligence. One of my good friends, she's based here in Hong Kong, Jen Chu Scott, the founder of Iron Capital, who invests into AI startups. She has this nice analogy. She says, we don't get on Mars by building taller and taller buildings on Earth. That's kind of the same as saying, if I build bigger models, then I'm going to get to AGI. You get a little closer, but not really. And when we say large, let's put this into perspective. Let's talk energy efficiency. Training one of these most popular, largely available large language models, one training run uses the same amount of electricity as watching 1.6 million hours of Netflix, 15 years worth of streaming. That's a lot of Seinfeld reruns you can do there. Right? And the other thing because of that is, apart from, just it's bad for carbon emissions, right? You can say, well, we have green energy, good on you, but tokens is compute cycles and compute cycles is cost. So taking the largest model doesn't always make sense. At the same time, of course, cloud providers like ourselves continue to innovate on the underlying silicon layer. We build, for example, some of our custom chipsets, Trainium and Inferentia, in addition to partnering with companies such as NVIDIA, et cetera, to further reduce that kind of electricity consumption. But it also goes into the space of use the right model, use a smaller model if you don't need the large model. Or use the model that is aware of your cultural references. Language is one thing. I mean, we recently started helping build some of these models out for Japanese, Korean support, working with AI Singapore, for example, on something very interesting here. I'm going to give you an example of that. It's called Sea Lion. In Singapore, they love these abbreviations. It stands for Southeast Asian Languages in One Network. Right? So it's SEA Lion. But it's a good example of saying, well, language is one thing. Most of the common models that you see here understand Bahasa Indonesia, but they don't always understand the contextual things. So if you used to say something like Kalau orang sedang di GBK, GBK is a famous stadium in Jakarta, right? You have and I'm not going to call out the specific model, but you see the one in the middle just hallucinated that this is a person that's usually in a deep state of deep relaxation. But the actual good answer, which was the first scenario here, which was sepak bola, you can watch football in that stadium. That's the usual activity, works out. So this cultural awareness is important. So as you build models, choose the right model. Companies like this and initiatives like this will train in the right direction. Now, lastly, I think when we build AI responsibly, there are a few components to it. One is the model providers, the cloud providers like ourselves. We have a responsibility to do so, but it's also about what you are building. Hallucinations are great. These pictures that I created, they're hallucinated, right? That's a powerful tool, but it's not always great when I actually need a correct answer. In those scenarios, think about that, chaining of models. Can I do an agentic AI? Call your existing microservice. Use the LLM as an entry point, but call a more traditional statistical machine learning model at the back. And look if you can bring in a human in the loop, if you can have those origin of informations. Lastly, that's my only sales pitch deck here. We obviously have a wonderful stack that allows you to build generative AI. So if you're interested in that, find us at the booth from all the way from building your own models to using fully managed models here to build your generative AI solutions securely and safely. With that, thank you very much for your attention.